So I'm going to talk about challenges and opportunities integrating artificial intelligence in business aviation. So I will skip to this subject and not talk about the military part of the activity of Dassault. The challenges and opportunities, I will try to make a focus on the Falcon aircraft family, and more generally, what is specific to business aviation with that respect. So I'm going to talk about increasing environmental stakes and issues. I will talk about the fact that we collect and analyze more data and we have less time to do it. So we have a problem of increasing complexity. We are going to have a short detour by discussion about contemporary and non-CO2 emissions, background and studies to show what is going to be related to the introduction of artificial intelligence in future aircraft preparing tomorrow's flight. And I will conclude with challenges and opportunities. So you will see, I will come back to this small picture that I have put on the right with safety on top, AI applications that serve the both safety, environmental stakes and issues, and competitiveness of our aircraft. So the Falcon family, I will be very quick, but you can see that there are some types. The most recent one is the Falcon 10X, which is going to be the major I don't know the name, but it is going to be the flag of Dassault with respect to business aviation. Falcon 6X is the last one and is already promising. And we have more legacy aircraft that are flying around the world. A takeaway message, the Falcon family, it's more than 1,200 Falcon operators in more than 80 countries for approximately 2,100 aircraft in service. So we are in the family of business jets with 10 times more airfields accessible than for commercial liners, but approximately 50 times fewer flight hours per year. So it's a scattered family. We have long-range aircraft that are capable of more than 10 hours flight, but we need to combine efficiency and flexibility, fulfilling the needs for travel over short jumps or very long distances. Usually, business jets are flying at higher altitudes, above liners, and we have a very high level of demand on operational availability. Customers buying new aircraft types show an increasing concerns about environmental impact criteria. So we have small fleets flying everywhere at all time with limited external support and people that can afford to pay for environmental impact criteria costs. So with respect to the increasing environmental stakes and issues in aviation, sustainable aviation fuel is to be generalized to all of our aircraft. Falcon F6X is performing its first 100% sustainable aviation fuel flights. It has just been done end of 2024. Falcon 10X is going to be compatible for 100% SAF upon entry into service. And we fulfill general climate environments. And I will come back to this focus concerning non-CO2 radiative forcing and energy sobriety that we want to introduce into the preparation of tomorrow's flight. So the climate commitments are at the heart of issues for Dassault Aviation, but let's go back to artificial intelligence. We have more data and less time to analyze this data. So we need for accelerated data analysis. We have data from flight tests, from development teams, and production data also. General aviation commitments for sustainability impose new technologies, and we need to optimize the aircraft operations, which requires new tools. We need new monitoring processes that are exploiting the data in order to maintain the high level of safety that is required. So AI applications will concern flight test data, accelerating the analysis, in-service data, trend monitoring, prognostic, and maintenance. At this stage, we will talk about operational availability and flexibility as the key issues that are at the heart of issues for Dassault Aviation. We are talking about continuing airworthiness monitoring. But we are also developing new products. So Falcon Care, for instance, is an innovative program that is designed to help customers realize stable, predictable maintenance. So the new multipurpose maintenance systems is equipping Falcon 6X and 10X. And we propose in-service trend monitoring, diagnostic, prognostic for enhanced maintenance, dispatch, and operational availability. Operational availability and flexibility again. At this stage, I will not use the term predictive maintenance. We are optimizing the flights using the current regulation. But we are developing future activities. So developing future sustainable aviation aircraft requires new technologies. Those new technologies are less advanced and we have less return on experiments. So we need new monitoring processes to maintain a high level of safety with those new technologies. For instance, more electrical aircraft. And more electrical does not mean that every thing is going to be electrical on the aircraft. Far from that. Towards extended continued airworthiness and continuing airworthiness monitoring, we need to take advantage of digital continuity, data, and artificial intelligence. So that's the way Dassault Aviation is preparing the future of general aviation with AI applications on data for sustainable aviation technologies, flight data, continuing airworthiness monitoring, and optimized operations. Increased complexity, that's the everyday landscape at Dassault Aviation. We have large-scale acquisition and monitoring of in-flight data from test flights to in-service data. We are implementing hybrid AI, combining data-driven machine learning with systems modeling. We try to exploit our ability to design statistical templates of nominal behaviors that are used then to perform trend monitoring and anomaly detection. This is applicable for general aircraft health and usage monitoring and preparing for future design of future aircraft. Dassault Aviation in this way is anticipating the future with the combination of symbolic and data-driven AI tools. We also investigate hybrid AI with respect to physics-informed machine learning, combining data analysis with, for instance, in this case, vibroacoustic and structural modeling. So this kind of models that have been learning on massive data are able to perform time frequency analysis for vibroacoustic anomaly detection, or that's the picture on the right side, or for behavior prediction. And in that case, what we expect is that in the case where we have measurements, we can test and validate that we are able to predict the right vibroacoustic behavior. So this is somehow called aircraft digital twin or aircraft health and usage monitoring. We also are concerned with the cockpit. So we need it for the purpose of designing our systems, designing our cockpits, and analyzing the way we organize and follow procedures on board our aircraft. We need objective measurement and analysis of human-system interactions. Combining machine learning and knowledge-based AI, we are in the process of developing new AI tools and methods for the design of new generation aircraft using those new technologies. AI tools also for the training of pilots, and especially monitoring the activity and the relationship between the pilot and the cockpit, the human-machine relationship. We intend to propose also crew assistance functions for appropriate human-machine adaptation facing any situation complexity, and human-made decisions using machine computations, and we put it this way. Dassault Aviation is anticipating the future with, in this case, hybrid data-driven and symbolic AI tools. Last but not least, coming back to environmental stakes, contrails and non-CO2 emissions, we have been working on this subject for years. In a few words, persistent contrails occur when you have two conditions. First, you must form a contrail. So this happens if and only if the Schmidt-Appelman criterion is verified. So it's a criteria that combines pressure, temperature, and humidity. And then it generally disappears, or it will not evaporate if and only if the area is saturated in ice and water. In this case, you have the formation of a persistent contrail, which can then have either a cooling effect or a heating effect. And globally, it has an impact on the environment, which is globally negative. So we need to do further studies to evaluate the impact and to see what are the appropriate measures. So to mitigate assessment uncertainties and consolidate predictions. This is what we have started to do with our colleagues from other airline manufacturers, like Airbus, Safran. And recent statistics performed on our fleet, going back to business aviation, show that the climate impact of the contrail of one flight may be high enough to motivate a trajectory adaptation with a detour or a change in altitude to avoid this contrail. This has been corroborated by many studies. 2 to 5% of flights are responsible to 80 to 100% of the non-CO2 climate negative impact. So you can see on this image that you have colding effect contrails. Typically, a contrail that degenerates in a cirrus in daytime is developing a colding effect, whereas a contrail that is developed and causing a cirrus at nighttime is going to produce a warming effect. So I'm oversimplifying, but this is the idea. So we need to mitigate that. How to do it? So FalconWays is a tool for trajectory and mission optimization that has been developed and is still under development for each type of Falcon aircraft. It allows to reduce CO2 emissions by selecting the most fuel-efficient route, and it allows to take into account all the flight plan constraints, and we plan to introduce the fact that we want to avoid creating persistent contrails. So these new capabilities for non-CO2 effects and CO2 emissions plus noise flight optimization is going to offer those capabilities to the Falcon family. So you can see in this case that we are really applying AI for attaining goals that are both at the crossing of safety, competitiveness, and environmental stakes and issues. So I'm going to finish with this slide. What are the challenges and opportunities? We are facing an environment with increasing environmental stakes and issues. We are also in the context of increasing complexity with more data and less time to analyze it. We need to prepare tomorrow's aircraft, pilots, and flights. So the system, the aircraft, but also the human and its training. And we are developing applied AI assistances, models, methods, and tools to do it, anticipating the future of aviation. Thank you.